What you're looking at is an AC-DC differential controller. It's used to regulate either an AC pump or a DC pump. Now, I don't have an AC pump or a DC pump today, but I do have an AC bench grinder. It's a 300 watt bench grinder. Now, this differential controller can regulate a pump up to 600 watts. Now, this is just a 300 watt bench grinder, but it's good for demonstration purposes so we can see how this differential controller works. Now, notice we have two probes on the differential controller. The probe on the bottom would go to the storage tank, and the probe on the top, this one here, would go to the collector. This is the collector temperature, 65.7 degrees, and this is the storage tank temperature, 66 degrees. Okay, so let's see if we can turn the pump on. Now, the pump won't go on right away. It has to reach a differential. Now, in a collector, the temperature can go quite high. It can get up to 250 degrees, sometimes even higher than that. So it's not hard to get the temperature of the collector. What we're interested in is the differential. Now, the differential for this controller, the differential on time is set between 15 and 20 degrees. You can see we've raised the temperature up to 72, 73, 74, 75, 76. Okay. So at about 83 degrees Fahrenheit, the bench grinder comes on. That's a differential of around 17 degrees. That's a good setting. Now let's see what temperature it goes off at. Oh, okay. So when this is 76 and this is 66, it goes off. So the differential was about 10 degrees for the off setting. Now, let's say we want to extract a little more heat from our controller. Well, what can we do? Well, we have this differential pot here that can adjust the differential. So let's set it right here and see what the differential off time is now. Alright, the differential on time will be the same. Remember, that would be about 17, 18 degrees, something like that. So, let's see, 75, 78. Alright, came on at 84 degrees. That's a differential for about 18 degrees or so. That's the on setting, but notice that now you notice the temperature dropping in the collector. It's down to 80 degrees. Now, as the temperature in the collector drops, we would expect the temperature in the storage tank to rise. But what we're interested in with this differential controller is the difference in temperature. So we want to see at what temperature, what difference in temperature the pump goes off. Now notice this is 69 and that's 72. So that's only a difference in about 3 degrees. Okay, so we've gotten closer to our storage tank temperature, within 3 degrees. We can adjust this pot even more and get even closer if we want to, but that's a good setting. That's up to you to decide how much heat you want to extract and how much power you want to conserve. Another thing I want to show you about this differential controller, and this is especially important if you're using it in conjunction with a photovoltaic panel connected to a battery. Because if the pump comes on longer than it should and the sun goes down and the pump's still on and it's not recharging your battery, you could drain your battery, and you don't want that to happen. So we have a protection circuit built in, so if the battery voltage gets too low, the controller shuts down. Now I'm going to show you how that works. And what I'm going to do, I'm just going to put a 10 ohm resistor across the DC power supply, and that'll lower the voltage to around about 8 volts. Okay? First we're going to have to turn the pump on. So we'll raise the temperature in the collector. Alright, 70, 72, 80. Alright, so the pump is on. Now when the temperature goes down too low, the pump will go off. But I can also shut the pump off by lowering the voltage. So I'm going to short the power supply right here. See, notice it's able to shut the pump off by lowering the voltage to about 8 volts. Okay.